jobs that are going to be like increasing in demand in the coming future. So all the technology, digital, data-driven jobs like data analysts, scientists, artificial intelligence and machine learning specialists, big data specialists, data engineers, digital marketing specialists, and process automation experts, and so on and so forth. Everything is now kind of moving away from those manual, laborious operating models that the companies had, and moving towards streamlining and getting more out of the data, and the jobs that are going to like that are decreasing in demand, things like clerical works for data entry, and assembly and factory workers. It's not just in within these white collar spaces that we will see that the advent of technology is taking over and making life easier on a lot of fronts, but also in manufacturing and construction related work as well. There is a lot of advent of robotics and so on and so forth. So things like assembly and factory workers and mechanics, machinery repairs, those kinds of jobs are also going to kind of go down in demand. So yeah, it's just setting up some context in terms of why data analytics is such an important and exciting field to be in. So yeah, I'll quickly move on to the next slide to show you some interesting examples in terms of what some major global companies are doing with their data, and what some real life use cases of these all these data related hype that we are talking about is. So Netflix, I know pretty much everyone is aware and is a user of Netflix. So, and it has been the number one platform since 2007, because they have used data and analytics to not only just provide people with personalized recommendations and marketing content, basis whatever you see. You must have seen that whatever you watch, basis whatever you like and dislike, you get very good suggestions. And if you end up viewing those suggested programs or TVs, movies, whatever, you'll most probably end up enjoying those. So, and it's not only that they are able to kind of predict what the viewership is going to be for some of the content that is not even out yet, and yeah, so for optimizing that content production, it's all driven by data in there. Similarly, WWE is one of the things, one of those success stories with data, where planning marketing strategies and fan engagement and so on is all driven by data. So Uber Eats is another interesting example wherein their algorithms can not only predict how much travel time is required for making that food delivery, but they also kind of have integrated information around how much time it would take to prepare that food from receiving that order. So their assignment delivery executive assignment algorithm is so highly optimized that their delivery executives don't have to reach at the restaurant and then wait for the order to get ready and waste some time over there and then pick it up and deliver to the end user. So it's all getting uh, very smooth and streamlined in Uber Eats with the help of data analytics. Zara, even in the fashion industry, Zara is you know gaining a lot of benefits of using targeted marketing basis, the information that they have collected from their past buyers and users in terms of how we can sell them more, what are the products that they like. We create according to that, and we market and sell them to those. We they use a lot of analytics in pricing models. So in every part across different industry verticals in different parts of their business functions, the data is so deeply rooted in terms of driving those decisions in terms of how we can make this better, that these are some of the leaders in their segments in terms of both the business and market share that they have, and all that is kind of driven by analytics. So moving on, I'll a quick kind of a summary and a very broad level definition of what data analytics is. So it's nothing but collection of the data and then analyzing that data to identify patterns and trends and find insights uh, to help the business decision makers in terms of how we can improve our operational efficiency that can bring down costs, how we can improve customer experience that can drive loyalty, and finally, how we can, expand and grow further. So in the end, data analytics is an enabler to the businesses in terms of how to achieve their targets and growth and so on. And this broadly involves three kind of main steps, so to say. So first is uh, developing and implementing those data collection systems. So all this data we know is getting generated. We looked at it in the first slide that in a minute we are getting millions and billions of data points that are getting generated. And but the first part of data analytics is how we collect and store them and ensure that that data is available to us and is of good quality so that can be used for our second step, which is analyzing the data. And analyzing the data is all about you know understanding what the business needs, which requires a lot of collaboration by the analytics folks with different business functions that are there. So to identify their business needs, whatever their targets and goals are, and then designing a solution around that, which requires use of statistical tools and techniques. And then in the end, you know, uh, all this information has also also needs to be fed back to the business teams in terms of and you know as insights, and telling them that this is what the data is saying, and this is probably the best action that you should be taking to achieve that goal. So broadly, these are the three steps of any data analytics assignment. So and at the bottom you can see these are the different types of data analytics, or we can call it the stages in terms of the maturity of the kind of analytics that is being used by any organization. So at the very basic level, we have descriptive analytics. So this is essentially looking at historical data and understanding what has happened. And the second stage of that, so for example, uh, people and say someone who is responsible for a company's profit and loss, and they want to see that in the last 2 quarters of their business, which product has kind of increased in sales and profits, and which has decreased. So that bit, just looking at that historical data that we have collected, and performance of all those different products, just getting to know that which is performing better and which is performing badly, essentially answering the question what essentially has happened. That is all part of the descriptive analytics. This is the most basic level of analytics, and a step further would be a diagnostic into whatever has happened, and we try to answer that why this has happened. So you know the example that I just took. So if a CEO of a company wants to see that, say, I want to understand which product has performed better in the past 2 quarters and which has not. So, and once we get to know that product A has been our top performer, and product B is like going down in terms of sales and profits, then we try to understand that why did it happen. So that is part of your diagnostic analytics. So uh, yeah, for that we need to kind of look at not just the sales, but several different factors in terms of maybe we can slice the sales by, say, different geographies, where it has grown and where it has not grown. We look for all the different data points that are available with us, that we are collecting, and we try to find that what is the main driver behind what has happened. The next stage of that is predictive analytics, where we basis what we have learned from the historical data that this is what happened, this is why it happened. So using this information, we try to understand what will happen in the future. That is where data modeling comes in, and we work with different statistical tools and algorithms that are available, from basic to very advanced machine learning algorithms that are out there in the market right now. So, and we get to a point where we can, so they we for predicting the future, we can never say for sure that this is going to happen. So we need to get to a point where we can say with a good amount of certainty that this is probably the most likely event to happen basis what we have seen in the past. So all that is part of your predictive analytics. Prescriptive analytics is building a step further on that, where once we have understood what has happened, why it happened, basis that we have understood what will happen, then we uh, so predictive analytics will probably, as I was saying, nothing is going to be answered with absolute certainty. So you can get several outcomes out of your predictive analytics exercise, and then adding that bit of you know consulting kind of a layer to this, in terms of letting the management and senior execs of our company know that the best course of action is going to be this. So that encompasses your prescriptive analytics. So as you can see, in terms of value and complexity, we go from descriptive towards predictive in terms of increasing value as well as increasing complexity. So yeah, that's how the entire spectrum of data analytics can be divided into these. Okay, I'll quickly move on to the next slide that I have. Okay, so yeah, now previous slide has set up some context in terms of what I'm trying to talk over here. So in the world of data analytics, there are three broad uh, you know roles or career options that are available. So data analyst is one, data engineer is second, and data scientist is the third. So data engineer is someone who is involved mostly with the first step that we saw in the previous slide, which is collection of that data and maintaining integrity and quality of that data. So data engineers primary responsibilities include data collection and ingestion in terms of say for example any company is using another third party company for conducting some marketing activities or conducting some customer feedback surveys, let's say. So what data engineers job is going to be is that whatever is the data that is getting generated at the back of these marketing activities or these you know survey responses that we are getting for customers, so their job is going to be collecting all this data from this third party and ingesting them into their own environment and their own storage spaces. And first, they'll get in all this raw data, which is not going to be readily usable, right? So it then involves things like integration and transformation, which we also call data warehousing. So all the raw data that comes in is is kind of it can be unstructured. So the analysts can't directly use it. So we need to build those relational models in terms of understanding what data fits where and curating specific tables and with well-defined structures and schemas and so on in terms of and letting the users know and providing them with data definitions that okay, this is the data, this is our structure, and now you can query from here. So that gold layer which is consumed by analysts is created by the data engineers in a data warehouse. And they also need to ensure that you know data is available, is of good quality. We are not missing out any important records when we are kind of going through the process of ingestion and warehousing. We need to ensure that data integrity is maintained throughout. That is also something data engineers will take care of. Data pipeline optimization and scalability and performance of that, because as I mentioned, we are working with billions of data points in probably in a minute for some of the larger organizations like Facebooks and Googles and YouTubes, but even for some mid-sized organizations, the numbers can be in millions and billions. So, and if it is driving towards growth, this is always going to kind of grow in volume. So the job of designing an infrastructure in terms of scalability, that with the growth in the data, that architecture that you have designed that can be scaled up and is optimized. It's not bringing down a lot of load on your servers. So all this part of getting that data from whatever sources we are collecting and getting it as efficiently as possible into a usable format is what data engineers do. The next side of this is data analyst. So data analyst is kind of a generalist. So there will always be some overlap between these three roles that you see on the screen right now. So data analyst is primarily involved with data extraction. So data extraction is nothing but getting the required data that you want to answer any question that has been put to you from the business side, from the data warehouse that data engineers have created. So extracting that data and cleaning it according to your needs, whatever you need, whatever you do not need. If there are some missing values, what do we do with that? And then analyzing and visualization of that data. So I'm sorry. Analysis is a very broad term, I know. So the data analysts will be asked, you know, any specific question, or they can just be asked an open question that, see, we want to, the business can come to you and say that we want to increase our sales next quarter by whatever X%. How can we do that? So in that case, getting that right data from the warehouse to find those insights that, for example, you can say that you should start focusing on the products that are selling more and, keep your focus a bit low on the ones that are not. And then that way you can increase your sales. But where we can do it, how we can do it, and when to do it. So all that comes from data analysis. So the most interesting bit out of these, if you ask me, is the data analyst job, where you get to work on very real life problems and work on getting some real insights that, and you see if action by the business, you see the results of that in real life as well. So data analysis and data modeling. So all this is done by a data analyst. Data scientist is the more advanced version of an analyst. We can say it won't be entirely true, but it's a field in itself. Which so data scientists are essentially people who are very good with statistics and are good in computer science as a whole, where they work on advanced machine learning models and AI engines and algorithm development, so that some of the things that can't be truly predicted just by analysis and some traditional tools that are available. So all those advanced things fall under the umbrella of a data scientist. So yeah, so these are kind of the three areas where you can get look to start your career. But obviously the most exciting, according to me, and the more easier one to target is getting into this data analyst role, which is why we are all here today, right? So we'll talk a bit about that now. So for becoming a data analyst, what are the skills that we require? So broadly, I've tried to kind of segregate them into these three categories. First is maths and statistics. Then you have your programming languages and tools, and these two are kind of your hard skills that you need to learn. So even if you don't have any background in this, you can always start and learn these. And the third one is your soft skills. So these are like you can't really put a value to these. So you need to you need to work on this, and you can build more around this. But yeah, I'll talk a bit about all of these in some detail here. So within mathematics and statistics, what I believe is important to understand is so firstly, you need to have that basic sense of uh, basically arithmetic and linear algebra to start with. So you must be comfortable, with basic numbers, the sums, additions, the percentages, and so on. That is probably what we have studied as a strong base. Luckily, in India, we have very good base for maths that is set up at a school, secondary and higher secondary level. So that sort of basic arithmetic and algebra is something that we should be comfortable with to start with. Then come some statistical concepts that I've listed down here. So knowing those basics of statistics, like what mean, median, and mode, standard deviation, and variance are, is also very important. A good hold on probability and correlation is also something that's important. And finally, uh, stratified sampling, hypothesis testing, and linear regression. These are some of the more, uh, you know, especially regression. Some of this is something that comes at an advanced stage. So when you get into that predictive analytics stage, when any problem that you're facing has reached that maturity that you have already covered descriptive and diagnostics of that, and you want to get into predictive, that's when you really want to know what a regression is, and how that works, and how it can be used to predict something that's going to happen in future. So these are some of the concepts. If it's something that you don't know right now, no need to worry much. So you can learn this. It will require some time to pick up on these, but I personally believe, even if someone is not coming from a maths background or an engineering background, where we are used to kind of work with some of these things already, people coming from different backgrounds also can learn this. It's not that difficult to grasp. So having a good hold on your basic maths and statistics is something that is definitely required in the world of analytics. Then come your programming languages and tools. So so once you know all these concepts, so how do you apply these? And when you're working with you know millions and billions of data points, how do we manipulate those to kind of find something as simple as percent distribution of sales between different products, and something as advanced as building a regression model, or a tree-based gradient boosting model using machine learning for predicting something in the future. How we do that? That is enabled by these programming languages and tools. So I've listed down Python and R. So these two are kind of the Python is hands down the market leader in terms of its usability. It's also very it's a versatile kind of a language. It's not just used for say statistical modeling, or just for analytics. It's a generic programming language that works very well with uh, data and big data handling as well. There are several good packages. It's free to use, and Python is definitely the market leader that you should be looking to learn. R programming is also it's specifically targeted towards statistical programming and machine learning and so on. All the libraries and packages that you find in R are more inclined towards that. So for your basic descriptive and diagnostic kind of stuff, R is not that recommended, because Python is kind of the most versatile programming language that you should try to use. Then there is SQL. SQL is also nearly a must-have in most of the cases, because that first step that I was talking about for a data analyst is data extraction, which is getting the data that you require and getting it into the form that you require from the data warehouse. Most of the data warehouses where that gold layer of data is stored is going to be a relational database, and any relational database that uh, we want to query, we can do that using SQL. So the first step for getting extraction and that basic manipulation of the data, SQL is also must have. SAS is another one, but this is kind of, I think, on the decline. Several organizations do use this still, especially in the world of banking and financial services, because it's more secure and has good defined uh, support teams and packages. All these are Python and R are both open source and are driven by general community of programmers. But SAS is like more secure. So especially organizations that work with financial information, so they prefer to use it a lot more. But this is kind of a dying language, so to say. And then we have some important tools that we need to know. Microsoft Excel is definitely where any analyst should start. And then we have Power BI and Tableau, which are essentially our visualization tools for dashboarding, for so all that descriptive and diagnostic stuff that we talked about earlier. So all that can be handled with Power BI and Tableau. And then Adobe Analytics, I wanted to mention because that is something that we see a lot in terms of our digital analytics that's coming up, and you know in terms of how different websites and web traffic is going on and so on. So all anything that's going on in the digital space, Adobe Analytics is something that's easy to use and is also widely used for those kind of analyses. So yeah, these are some of the important ones. On the soft skill sides, guys, I think the first and most important skill to have is problem solving and critical thinking. So even if you learn all these programming languages, you get to understand all these mathematical concepts and statistical concepts, it won't be of much use if you don't have that analytical mindset. When the business comes to you and says, you know, we want to just take an example, whatever, I want to achieve XYZ, then how can we achieve that? That first part of your before you even get to your data and start extracting data and start thinking about what algorithms we can use and so on and so forth, we need to break down that problem in terms of smaller problems and knowing how we can tackle each of those. So problem solving and critical thinking is the most important soft skill to have. Then general, data crunching. What I mean here is knowing how to, slice and dice your data, where to cut it, with what lens to look at, knowing your data in and out in terms of what is available. So that is also something that's very important. The better you know your data, the better you can design your analysis. So, and fine. And the third one that I've mentioned here is visualization and dashboarding. So, in terms of presenting that result to the business teams, to the stakeholders, you need to be showing them something that's very intuitive and visually pleasing. You can't be giving them a dump of numbers. You need to people like us who are analysts, we are comfortable looking at numbers and finding what we want to look at. But people from the business side, they generally want something that's clear cut, that tells them, okay, this has happened and this is what they need to do, very clearly laid out. So how you present your data, how you visualize it for the stakeholders in dashboards, reports, whatever. So that is also very important. That aesthetic sense in terms of what to look, what they want to look at, and how they want to look at it. Having that sense is also very important. Then definitely, having domain knowledge and business acumen is important. So knowing that's something that you get to learn on the job as well. When you get to work in a specific industry, you get to know how that business works. You start working in say automobile industry. What are the ins and outs of that. So you start working in a financial services industry. How that works. So you need to keep on building that knowledge for having those better and more coherent conversations with the business teams. So that's also an important skill to have. Collaboration and teamwork, definitely you will be working a lot. You won't be just sitting in silos and doing whatever you want. You have to work with the business to understand what they want and how we can help them achieve that value. So that collaborative mindset is also a must have skill set in terms of those soft skills. And finally, yes, communication and presentation is also very important because um, yeah, I mean, it goes without saying, if even if you have done a really good analysis, you can predict what the future say our sales forecast is by with a 90%, 99% accuracy. But if you're not able to communicate that well to the stakeholders and why they should follow some path, then your analysis will never be acted upon and you'll never get to see what it resulted in. So all these skills are like at a starting point you need to have uh, you know some of these covered. I mean, not all of these, as I was saying, in mathematics and statistics, I guess regression and the predict your hypothesis testing is something you can learn at a later stage. In terms of your programming languages, you need to learn either R or Python. Python, go for it, and SQL, you should go for it. Others are optional. Uh, Excel, Power BI, or Tableau, one of those visualization tools is important. Adobe is optional. And for soft skills, I guess problem solving, having good communication, that collaboration mindset, and having good aesthetic sense in terms of how to visualize that data. But these are the ones that you really need to have. I'll quickly move on. I'm almost on time, but yeah, this is an important slide. So, how to start? So, what I think is the first point should definitely be, understanding those basic mathematical concepts and start with a basic tool like MS Excel first. So, in for understanding your arithmetic and algebra, I'm sure that's something we already covered during our schooling days. So, but if you need to brush up, do that. And for statistics and other advanced things for testing, regression, uh, there's oh, there's a good free resource that is available online that's called Khan Academy. Some of you might have already heard of this, but I believe it's the best source. It explains everything in very easy to understand English and with examples that make some of these statistical concepts that seem to be abstract. Uh, they kind of show it with such good real life examples that anyone can easily grasp. So I highly recommend going through Khan Academy videos, free source available on the internet for any statistical concepts. So and for MS Excel, there's a lot of free content available on Microsoft's website itself. There's a lot of stuff available on YouTube. So you got to know your basic formulae and use of some basic functions like pivot tables and what charts to show. So these should be where you start and kind of spend. If you're just starting, then you should spend at least 4 to 6 weeks just learning your basic maths and MS Excel. Moving on, I think the next step should be learning that programming language that you want to do with. According to me, I believe Python and SQL are the ones that you should go for. These are the most sought after in the market, and these are probably the easiest to pick as well in terms of the way they are syntactically. You can easily learn to code in these languages. It's just like writing in English. Of course, you have to understand some of the advanced nuances, but that can come at a later stage. But to just start and get to that entry level, you need to, I think, understand the basics of how to, extract data using SQL from the data warehouse and how to manipulate it and uh, using Python. So the next step after you have done your programming language as well, then you should start building your knowledge of visualization tools like Tableau and Power BI. My personal recommendation is Power BI is the market leader right now. Most of the organizations are that were previously using Tableau are also now kind of moving to Power BI. So Power BI is the one that you should be looking at. It will kind of help you not just from the technical perspective, knowing how the tools work, but it'll also uh, help you work on those soft skills in terms of your dashboarding and visualization, how to present the data in more meaningful way. You'll find n number of ways of showing that, but which is the most effective? You'll find a lot on the resources that you'll find for Power BI and Tableau, both. So that should be your next step. And then the final step is to start building your domain and industry knowledge, and also try to get some hands-on practice with some real life scenarios. And a good way of doing that is to participate in online forums, start talking to people about stuff. You'll understand the industry jargons, not just the data analytics industry, but whatever industry you as data analyst will be serving. So try and understand business terms related to that. If you're getting into, say, financial services, you need to understand what jargons and terminologies are used, what's a P&L, and so on. So for that, there are several free resources available. Investopedia is a good one for all the financial stuff. And for that hands-on practice for real-life scenarios, Kaggle, you must have heard, Kaggle is a good source where a lot of competitions are held. You get a lot of good data sets, good problems there, and they, keep on doing a lot of competitions you can participate in. It'll help grow your uh, knowledge, give you that hands-on experience, and if you get to achieve or build something very good, that is something you can add on your resume and your portfolio as well. I as a recruiter, if I see someone who has won a Kaggle competition, I know this guy must be good. So so keep once you have built your knowledge and understanding, start practicing on these real life scenarios. Work on your soft skills like problem solving, communication, and presentation skills. So this is not after all this in sequence. This should be worked in parallel with whatever you're doing. So start speaking with your friends, your family, whomever you want to speak with, and start just giving them some presentation about some random topic in terms of that can kind of improve your verbal communication, and also help you with your thought structuring, that how we want to show all of these ideas that we have in our mind. Because if we are not communicating them well, then those ideas will get lost, and there's no point of it, there's no fun in it. Yeah. So, and finally, once you feel you're ready, you have a grasp of basic maths concepts, you have learned a programming language, and you are comfortable doing some uh, basic analysis in these online forums. You then need to work on building a good resume, a good LinkedIn profile, showcase your portfolio, showcase any good codes that you have written, so save them on GitHub, uh, have it in your resume, have your LinkedIn profile, have any Kaggle related, competitions that you've entered and won, have it there, list down a good resume. You can find several good resume templates, and my personal recommendation is that please do not make your resume too lengthy. I always like to get a precise one pager resume that covers most important parts that you want to showcase. To be honest, I absolutely hate people who make like 5 7 page resume listing down 10 projects that they have worked upon. That is not required. So keep it simple, but keep it comprehensive. And yeah, then just start applying for level jobs and begin your journey in the world of data analytics. Yeah. So as I was saying, there are several good sources available online. You have Coursera, Udemy that give you good paid, courses and certifications that always add value. W3 schools and YouTube's, so you get a lot of free content here. So yeah, just go out and you have to have that learning mindset. And I guess in depending on how much time you are putting in and how serious you are, I think in 3 to 6 months, even if you don't have any background with maths, stats, whatever, in 3 to 6 months, you can get to a level that at least you can start uh, looking at some job options and getting to that entry level job. If not, you just keep on learning. You never fail, you know. So yeah, that is that, guys. I'm open to questions, comments, thoughts, whatever.
Thank you, Shailabh. Guys, if you have any questions to ask, you can put in the chat box or you can unmute yourself and ask these questions. Uh, Shailesh, I have one question like for the
Mhm.
larger audience. What are
Mhm.
some of the different types of data analytics jobs that are available for the recent graduates? If you can throw some light on that.
Yeah, I mean, as I was saying, the easiest one to get into is as I was mentioning, the three parts of data analytics is data analyst, data engineer, and data scientist. Data scientist is something of a more advanced thing that will require a lot more learning and expertise to get into. But to start as a data analyst for just working in BI and reporting and just trying to set that basic level of analysis in terms of what has happened and having that lens. That is some ways that recent graduates should look to start. And yeah, data engineer is also it's the second in terms of complexity and the learning time, lead time that would be required. And data scientist is the third most complex and will require the most time to get ready for a job in that space. So getting into data, uh, getting a job as a data analyst is what you guys should be targeting.
Great. We've got another question from Bhargav.
Mhm.
How to improve programming skills in Python, SQL, SAS, and other tools, and also
Mhm.
how they can go about choosing their projects.
Okay. So, see, there's the answer to that is very simple, guys. You need uh, to improve your coding skills. I think there is no shortcut. It's all about practice. You can learn all your syntaxes and algos or whatever, but running them again and again in different scenarios, how to work on it, that's the only way to get better at coding. That I I believe this is a very this must be seeming as a very generic statement, but that is the hard truth. I mean, to improve your skills, you just need to practice, practice, practice. So that you once you write a course, uh, you know, code, you'll get to a level, especially that happens with you start with the SQL first. I think that's the easiest programming language to pick. So start with SQL first, start writing codes, then start looking for ways how that can be optimized, because they in coding itself there are like several different ways of doing stuff. You can, for example, if some of you have some context about SQL, so you know there are two ways to filter any data. You can use a where clause, or you can create a temp table and do an inner join to that. So try to see and run that which is working more efficiently, which is giving you results faster. So try and optimize that code as much as you can. Then apply that same scenario in a different environment, a different data set. See what happens. Keep on repeating that process, and that's how you improve your coding skill. You write more optimized, more efficient codes. Once you have a grasp of that general programming, you know, skill, I mean, that that can be translated to another language very easily. But getting to that level that you're writing good, efficient codes, you just start with one. You should not get into like all the languages at once. Start with SQL, start with Python, and just stick with those two. No need to try to become a jack of all. Try to be a master in one first. So yeah, SAS वैस की जरूरत नहीं है. Just go with SQL and Python. Projects, of course, for projects you can, as I was saying, Kaggle is always a good source for finding good projects. There's another good free source available on the internet is Code Source or something like that. I'm forgetting the name, but there are several good projects that are available with very robust data sets, good volume data sets that'll test your you know coding skills to the full. So as good as you can be in all these, the easier it will be for you guys when you get into the actual job and start working on life projects. Make sense?
Yeah, I think you have briefly answered to Bhargav's question.
Hmm.
Thank you so much, Salah. So we have another question from Kriti.
Hmm.
How they that they want to know how to choose which field is good and comparatively easy to start in data analytics.
See that that varies, to be honest. But what I feel generally, the field that's easiest to pick is you know BI and reporting side of data analytics, which is essentially descriptive analytics as a data analyst, because that essentially it's just looking at what has already happened and finding some insight into why it has happened, and doing that is much easier if I'm not saying it's very easy. It's easier if you know your data, if you know the business, combining that knowledge, getting some good reports out to your business stakeholders is the easiest way to kind of start. I know I'm not answering that question very well because it's very subjective, to be honest. But yeah, I guess start with BI and reporting. Target your data extraction with the SQL, and target a visualization tool, Power BI preferably. If you get good at both, you can land a job in that space easily. That will require the least amount of lead time in terms of bridging the gap in your skill that you currently have, and you learn new skills. So I think that's the easiest.
I hope that answers your question, Kriti. So we can take one more question as in I'm again
Yes,
asking
please.
the question.
Hi.
Yeah,
Sure.
basically it's for the larger audience only once again.
Mhm.
What are some of the common mistakes as usually the recent graduates do when they apply for these data analyst jobs, and how can they avoid these pitfalls?
Hmm. Okay. Interesting. Well, I would imagine. Well, to be honest, I haven't spoken to any recent graduate recently, to be honest. But I believe the thing that I believe people make mistakes around is to, you know, not knowing what you're putting in your resume. I I believe you don't need to put in like a thousand things in there and not being able to back them up when the interviewer asks you. Even if you put two or three good things that you know in terms of your technical skills that you have worked on as your academic projects or outside your own space, and in your learning phase you have worked on projects, just put in those. If say during your learning phase you have worked on 10 different projects, the ones that you believe, one or two that you believe were the ones that you can talk about at length with confidence, and you can back it up completely when the interviewer is going to cross question you, put that in your resume and back it up fully. No one is looking for someone like who is who is a Mark Zuckerberg who knows everything. No one is looking for that. So just my advice is put a lot of effort and a lot of scrutiny in what you are putting in your resume, and be ready to back it up fully. That that is the most common mistake that I see. Some people, they go and look at different resumes, that this looks like a good one. Maybe I can, you know, just poach in some project from this resume, put it in mine. I can do some bit of studying around what was done here. But if you are caught on the back foot and you can't answer some when the interview starts going into the details, then that you're going to be clean bold after that. So just don't make that mistake, I think.